we have here these points. These points means from here the 19 volts goes to 1, 2, 3, 4, 5, 6 to 7 place in the motherboard. So let's check where this 19 volt goes. These two MOSFETs and this coil and these two ceramic capacitor is the first channel of the CPU. Here we have another channel. Normally we should find 19 volt in one of these two MOSFETs. Let's check for example this. As you can see, this MOSFET holds the 19 volt. This is the back of the CPU circuit. The first channel, as we said before, and here we have the second channel also. For every channel, there is two capacitors. I can draw for you the circuit diagram for this CPU circuit. So let's draw it right now. So the CPU circuit, okay? So here we have two capacitors, okay? So this is a chemical capacitors or a polarized capacitors. We have another polarized capacitors exactly as the motherboard, and then here we have the coil L. We have here L1, okay? For example, here this is the C1 and the C2, and here we will get to VCC core. The VCC core is the main power for the CPU, okay? So we have max 8770. Let's go to the computer and see its circuit diagram. We can just put the reference here or go to Google. So let's see Google. Let's write down max 8770 as you can see and press enter. Let's select the first result. Here we have max 8770 datasheet PDF. In the PDF file, we have max 8770 and we have many other references that is similar to max 8770. So let's click here, then click here, download. We have the file with 47 page. So here we have max 8770, max 8771, also max 8772. So all these are interchangeable. This is what we need, CPU core power supplies. Here, as you can see, this is the output power of this IC, VCC core, from 0 to 1.5 volt, as you see. Based on this ID, this IC know to power the exact power that the CPU need. Here we have output, as you see. As you see, we have here the input Vin from 8 volt to 24 volt. Let's assume that the Vin is 19 volt. So the 19 volt will go here, as you see, to power the IC first, and then will pass through this MOSFET. As you see, we have here drive high 1 to activate those MOSFET, and here we have drive low 1 to activate this MOSFET, and then the VCC core will pass through this coil, as you see, and will be generated, as you see here, the VCC or the output voltage. So this is the first channel. We get here output, and also here we have another channel. As you can see here, we have here these points. These points means from here, the 19 volts goes to 1, 2, 3, 4, 5, 6 to 7 place in the motherboard. So let's check where this 19 volt goes. So let's see the other side of the motherboard. So as you can see, here we have the adapter. Okay, so let's see. Always we should put the black probe in the ground, as you can see. So let's put it here or even here. Okay, so here this is the back of the power jack. As you can see here, we have this resistance. Okay, this resistor is the current resistor sense. Okay, so let's check. Normally we should find here 90 volt. Let's check. So let's check. As you can see, we have here 19 volts. Do you see also these points? a lot of points in it means the 19 volt is distributed from this resistor to the whole motherboard. So let's look for this 19 volt in the whole motherboard. So let's put this probe here, for example. Okay, so here we have the first circuit. This is the CPU. This circuit is for the CPU. So this 19 volt should go here. So let's check this MOSFETs. Okay, so the first MOSFET. We don't have here 19 volts. Let's check here, for example. You can just check until you find the 19 volts. Okay, so here we have 19 volts. This is the drain. This MOSFET, we have 19 volts here. These two MOSFETs and this coil and these two ceramic capacitor is the first channel of the CPU. Here we have another channel. Normally we should find 19 volt in one of these two MOSFETs. Let's check, for example, this. As you can see, also this MOSFET holds the 19 volt. This is the first channel and this is the second channel. Okay, of course in the back of this channel we will find other components. So let's check. Do you see? As I told you, this is the back of the CPU circuit here. So here the first channel, as we see before, and here we have the second channel. Also, for every channel there is two capacitors. Okay, if we check this capacitor, nothing here because the laptop motherboard is not yet powered. Okay, so this 19 volt is present in the first terminal of each MOSFET in each channel of the CPU circuit. So also here we will find 19 volts somewhere here. This is another 19 volt for this channel. Here also we have here another 19 volt for this channel. So for each channel we have two MOSFETs here and two MOSFETs in the other side and two capacitors and one coil. For the other channel we have two MOSFETs or four MOSFETs, two capacitors and one coil. And here we have, as you see, 2 PF capacitor for each channel. I can draw for you the circuit diagram of this circuit for this CPU circuit. As you see here, we have the power management for the CPU. Okay, I will draw for you this circuit diagram. So let's draw it right now in order to understand deeply. So the CPU circuit. So the CPU or the processor circuit. Okay, so we have seen that we have 4 MOSFETs in every channel. Okay, so let's see that here we have 19 volts. Okay, this is 19 volts. Okay, this is the power rail. Okay, here we have the 19 volt. Okay, here we have 2 PF capacitors, as you can see. This is a ceramic capacitor connected to the ground. Okay, I mean this 2 capacitors, as you can see, this 2 capacitors. Okay, we have 2 capacitors here. Then here, as you see, we have 2 MOSFETs. Okay, we have here the first MOSFET here and the second one here. Okay, as you can see. So here we have drain, as you can see, and in this MOSFET also we have drain. This is drain. So this connected to drain and this also connected to drain. So here we have source, as you can see, and we have the gate here. Source and the gate here. Okay, So these three MOSFETs are connected together, or these three terminals are connected together. So, and then connected to another MOSFET. So the drain of another MOSFET over here, as you can see. Okay, this is the drain of another MOSFET, and the source of this MOSFET is connected to the ground. Okay, and here we have the gate. Okay, so the source of this MOSFET also is connected to another MOSFET. Okay, as you can see, and the source of this MOSFET is connected to the ground. Okay, and we have here the gate. Okay, so here we have the power management. As you can see, this is the CPU power management. I mean this IC. Okay, this IC. So here we have, as you can see, 4 gates. So this gate will go directly to the power management. Also this gate also, as you can see, also this, and also this gate also. Here we have the power management. Normally, the name of the signal here, so let's assume that here we have the Q1, okay? Here we have the Q2, Q3, and Q4. This is the first channel, as you can see here. Okay, so the first, as you can see, the name of this gate is DH1, drive high 1. Okay, and here DH2. Okay, drive high 2. Here we have DL1 and DL2, drive low 1 and drive low 2. Okay, so as you can see here, we have, as you can see, these capacitors. Okay, 2 capacitors for each channel. As you can see, we have here 2 capacitors with 2 MOSFETs, and in the other side we have other 2 MOSFETs with coil. Okay, as you can see. So here we have 2 capacitors. Okay, so this is a chemical capacitors or a polarized capacitors. We have another polarized capacitors, exactly as the motherboard, and then here we have the coil L. We have here L1. Okay, for example, here this is the C1 and the C2, and here we will get to VCC core. The VCC core is the main power for the CPU. Okay, so the same, this is just the first channel. Okay, this is the first channel. We have here another channel exactly like this channel here. Okay, so we have here, as you can see, also we have here also, so we should have here 19 volts. Okay, okay, here we should have here 19 volts with, as you see, 2 PF capacitors or ceramic capacitors, as you can see. Okay, and of course we have 4 MOSFETs. Okay, 4 MOSFETs, as you can see, 4 MOSFETs. Okay, the drain of this MOSFET, here we have the drain also of this MOSFET. The source of this MOSFET, as you can see, is connected to the drain of this MOSFET, and then the source is connected to the ground, as you can see, exactly like this. This is the second channel. So here also we have the source of this MOSFET, as you can see, is connected to the drain of this MOSFET. Okay, and here we have the gate here, also the gate here. So this gate is connected to this IC, also this gate is connected to this IC. Here also we have gates, and here of course we have source connected to the ground, and we have gate. This gate also is connected to this IC, and this gate is connected also to this AC. So the name of this gate, as you see, this is the drive high. So this is, as you see here, so let's assume that we have a Q5, Q6, here we have Q7, and here we have Q8. Okay, so here this is the high MOSFET. So here we have, this is, so drive high 3, this drive high 4, as you can see. Here this is the low MOSFET. So here we have the drive low 3 and drive low 4. Okay, for this MOSFET. Also here the same, as you can see, we have other two capacitors, as you can see. So these capacitors, so these two capacitors is this, and we have other two capacitors, as you can see, other two capacitors. Let's draw it here with the coil. So we have here the chemical capacitor of the second channel, as you can see, okay, connected to the ground, okay, and also another chemical capacitor connected to the ground, and then we have the coil here, and here we have the VCC car. Also here we have the VCC car for the CPU. Okay, so this is two channels. This is the first channel and this is the second channel. So always this 19 volt normally is coming from the source of power. It's coming from the current sense resistor, exactly here, as you can see. Do you see here? So we have here the power jack here, or the connector for the power. In the other side, as you see, this is the resistance, the current sense resistor. This point means the voltage is distributed to the whole motherboard from here. So let's check the power management IC for the processor in order to understand how to analyze and how to read the power management circuit diagram. So here we don't have the power management over here. Let's see the other side of the processor. So as you can see here, this is the power management IC for the processor. So let's check the reference of this IC. As you can see, so as you see, we have max 8770, max 8770, as you can see, with how many pins in one side. So let's count the pins. So this is the pin number 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 pins here. Also here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10. This is 40 pins in this IC. 40 pins, 10 in each side. So we have max 8770. So let's go to the computer and see its circuit diagram. So we can just put the reference here, okay, or go to Google. So let's see Google. Let's see in Google. Let's begin from the beginning. Okay, so let's write down max. So 8770, as you can see, and press enter. As you see, let's select the first result. Here we have max 8770 datasheet PDF, as you can see. Okay, let's press the first result. As you see, the same. Okay, here, or you can even go here and write down here max 8770 and press enter. As you see, the same result. So let's click here, as you see, in the PDF file, we have max 8770, and we have many other references that is similar to max 8770. So let's click here, okay, then click here, download here, okay. So we have the file here, as you see. We have the file with 47 page, okay. As you see, you can download it here. So let's see, okay. So let's see from the beginning. So here we have max 8770, max 8771, also max 8772. So all these are interchangeable. Okay, so max 8770 gel phase quick power management control for EMVP6 plus CPU core. This is what we need, CPU core power supplies. Okay, as you can see here, we have some features: single gel phase quick power management controller. Here, as you can see, this is the output power of this IC. So, as you know, for the computer or for the laptop motherboard, the main power that is generated by this IC for the CPU is called VCC core, about from 0.7 to 0.2 volt. So, for this IC, it generates from 0 to 1.5 volt, as you see. Okay, I have here many features. As you see, this is electrical characteristics. You can find here parameters, symbol, conditions, the heat, the minimum and the maximum of the heat. So as you see, this is the pin configuration. Okay, let's zoom in a little bit. We will see here some important signal. The first signal that we will see, as you see, we have here the ID, as you see, about 7 signal. Okay, 1, 2, 3, 4, 5, 6, 7, as you see. Based on this ID, this IC know the power, the exact power that the CPU need. Because some CPU can need, for example, as a VCC core, 0.9 volt DC, but others, for example, can need 1.1 or 1.2 or 1 volt, etc. So based on these IDs, as you can see, this IC will generate the VCC core. As you see here we have output, as you see, CPU VCC output here. Okay, so as you can see here, we have here two MOSFETs, and here also we have two MOSFETs, because always the CPU contain in its channel about 2 MOSFETs or 4. For this CPU, it contain here 2 MOSFETs as a high MOSFETs and other 2 MOSFETs as low MOSFETs, as you see here. This is low MOSFETs. Okay, so here, as you see, we have the V in. So as you see, we have here the input V in from 8 volt to 24 volt. Let's assume that the V in is 19 volt. So the 19 volt will go here, as you see, to power the IC first. Okay, and then we'll pass through this MOSFET. As you see, we have here drive high 1 to activate those MOSFET, and here we have drive low 1 to activate this MOSFET. Okay, and then the VCC core will pass through this coil. Okay, through this coil, as you see, and will be generated, as you see here. This is the output, the VCC, or the output voltage. So this is the first channel. Okay, so this is the first channel. It contains 2 MOSFETs with inductors, as you can see here. So we have LX, always LX is the output. LX1, as you see, we get here output, and also here we have another channel with 2 MOSFETs. So this MOSFET should receive here V in. Let's check. As you see, we have V in here. As you see, it receives here V in, as you can see, and then it will be activated. We have here drive high 2. This is the second drive high 2, And here we have drive high low for this MOSFET also. Here we have inductors, okay, as you see, and we will get here output, always the same output. The output is the VCC core for the processor, okay.